already. Oh, I need to go live on YouTube. Okay, going live on YouTube and starting now. This is Codeforces 7:30, virtual participation. Hi chat, hi. The difference between A and B doesn't change, so we want that to be. We want to make this an excitement. Oh, that's templates from Google Code. Are they distinct? 0, 0. Also, I want to make them divisible by this. I think this works. I got the difference and I saw how far away I need to change them to make them divisible by their difference. 3, 2, nope. Diff minus 1. Right. B. Oh, I know what I want to display. Solved. And parts, something about the nth part. So I guess for now that doesn't matter. There is an array of size n. We sum up over differences. You can move values around. So we will make everything equal. I think so. Like here, we made everything equal to 2. Hey dumb. Wait, I'm dumb or somebody else in the chat? This is the average value, are actually lower of them. Now, how many times we have the bigger value? That many. Okay. So that many times we have this value, that many times we have this value. For example, if we have n equal to 5 and the sum of values is 27, bad example, 42, from this I will know that every value on average is 8, but 2 of them are left. The remainder is 42 modulo 5 is 2. So 2 of them are actually bigger than that. This is what I will have. Now given this, what's the sum? It's the number of 9s times the number of 8s. Multiplied by 2 maybe. Answer times that. Well, not quite there. Okay, this I don't want to be used. Times 2. 842. Oh, it's not doubled. So apparently we don't go ij and then ji. That was problem B. You forgot times 2 at line 48. Yeah. It's faster for me with such easy codes to figure it out myself rather than look at the chat. And you know, it's more of me participating in a contest, not us together. So don't spoil too much. Polls in the chat. Well, that would be nice, but not this time. Right, problem C. What is happening? Races? They don't define a race, and then they are talking about races? What is reward slip? Yeah, I don't understand the story for sure. I get CMPV. If probability of doing what I did is smaller than V, then I cannot repeat this anymore. And instead of 3 possibilities, I will have 2. Otherwise, the probability is reduced by V. As a coordinator, I would never accept this statement. P. The third type of item is the losing one, right? Right. Is it true that we will play this game only for a few turns? We start with some probabilities, say 0.3, 0.35, 0.45, 35 again. If I hit this, I win immediately. If I hit one of them, then even if V is just 0.1, then what happens if I hit the first one, or let's say the second one, is that this gets decreased by V, and V over 2 is added to the other 2. Like this. Well, the last guy will eventually reach 1. So this game will last at most 2 times 10 turns, because v over 2 is added to third probability, or at least this. So I can iterate over all possibilities in time to add 20th power for whether first or second is hit. If third is hit, then that's game over. Most 4 decimal places. Maybe I want to change them to ints. Nope. Right. So with some probability I got here. Initially that's probability 1. C is good, C was stupid, C was absolute shit. I think it's bad, it's a bad problem. With this probability we made another move. Otherwise, if a is greater than 0, then with some probability we go to A, okay, I see, meaning of A and V, A minus whatever is taken, B plus take over 2, C plus take over 2, unless those were already 0. Unless that was already 0. Yep. Very ugly code. And with some probability we stop the game. I think that's it. Too few arguments and epsilon doesn't exist. Yep, all good. I understand that this is from some game. Racing game, I guess. I mainly played Need for Speed Underground 2, but it's a very bad statement. I hated it. Now, D. There's easy and hard. Interactive problem. passed in one try. If you pass samples, then I think you need to pass all the tests. I don't see what I could mess up but to pass samples. K is 2, K up to 100. And nobody solved hard yet. But let's try to solve hard. We define some kind of XOR in base K. What is that? Oh, to this number. If XOR is like plus, then that is y minus x. Y minus x. I think if I mess up, I should guess the same thing again and it will be cancelled. But I need to make sure about this. That doesn't make sense. Or maybe. Yeah, I need to analyze it. XOR wise, something like this is true. So the new z is y minus x modulo k. Well, y is a number I chose. This is my guess. This is hidden. Hidden becomes this. If I guess again the same thing, then this is equal to hidden. So I think after two incorrect same guesses, I have the same hidden password. Oh, but that's useless, is it? There are a lot of test cases. Okay, but it doesn't matter because of it. If I understand correctly, it's easy to do in 2n queries. If what I said is correct. So we guess something, then we revert it by guessing the same thing. Now I kind of need to guess every next number. For every next number I need to understand what it is equal to now. And always this happens. My current guess minus hidden. So everything previous gets taken with a minus. If this is the initial hidden number, and then my first guess is called G0, let's say, then G1 and so on, then I think that we'll have something like this. Or maybe the most recent guess, and then all of that. This is the new number. I need to maintain this sum. Modulo k. The sum of my guesses with minuses. So I will maintain this initially equal to 0, and always I will do some guess is some guess minus new guess. I will do this, so it will be maintained here. I need a function for subtraction. Modulo k. Yep, I think that's it. Okay, will be global, so I could easily do this. Or do I want to keep vectors maybe? I guess not. Well, this we take a digit of k of a, digit of b, which means y plus k modulo k, I think. Right? Gather digits from the last. Yeah, that should be fine. X is sometimes with plus, sometimes with minus. I see. Twice subtracting will give me addition. Hidden here. So, yeah, this is adding, else subtract. If I read a response, if it's 1, then it's problem solved. I don't need else. And it's updated. Okay, that's something. Obviously, in Codeforces you want to submit this immediately. Doesn't matter to which problem. I prefer D2. Because if you get wrong answer, it doesn't hurt. On first test. Wrong answer. Actually, I should now think about it. NK. Well, I messed something up. But what? 0, 0. I'm asking about 1. That's reasonable. And here I'm asking about 3. Maybe I should verify that. If the hidden number is 2, then it's a different number. Did I mess it up? That is equal to my guess minus the hidden. My guess minus the hidden so far. Shouldn't it be the other way around? Hidden minus some guess? Hidden becomes guess minus hidden. Alright, maybe I should always do that. I'm confused. I think I simplified it too much. There are two things going on. One is that the sum keeps getting modified, and two, that I need to ask about something. The sum guess should consider my guess. Okay. So what I ask about is this. Alright. Some guess. And now, knowing that I asked about that, I need to use that fact like here. I think it's this. Comma some guess. I just want to see that something changed. Okay, something did change. Normally I implement my own function. Oh, test first test passed. Do I need to submit D1? I don't know that. It's some big time. Yes, I need to submit. Right, final pursuit, last problem. Here we go. Quick look at standings. Yay, winning. Very long paragraph of story. permute, but permuting. Right. There is permutation we applied. I need to find a permutation that was used to get from standard cube to this one, and then I want to color every node so that from each node it would be possible in one move to get to every color. Then coloring should be easy, or not. I wanted to say sum of bits. Yeah, it will be XOR of something. I know puzzles like this one. I'm quite sure that color will be chosen with an easy function, like sum of positions of bits where there is a 1, something like that. Let's focus on the permutation. One vertex I need to call it 0. Then I'm looking for two neighbors with a common neighbor, and this will be one side. Then I look at any neighbor of 1, and for a 2 I want to apply the same process, just not using previously forbidden nodes. And then I connect that. Okay. So I will have a recursive function, and given a node and the dimension I want to get, I will first grab any neighbor, I think, then any other neighbor, and for him I want to find a neighbor, connect into a square, then grab another neighbor. We iterate over neighbors of node 1, and for each next one we require them to create a hypercube of some dimension, like 0, 1, 2, and then we connect respectively. It's not that I need to connect. If I'm 0, 1, then 2, 3, 4, 5. I think I need to first finish my side, and only then go the bigger one. It's quite abstract problem, it's easy to mess this up. Maybe abstract isn't good name, but still, it's easy to think that you kind of know the solution, but you actually don't. We have test cases. Yes, of course we do. Given a node, let's say node A, and I guess dimensions. Do I want to return maybe a vector? Three blue, one brown. No. Talking about traversing hypercubes or mapping them, that's not just in one video in the internet. Read the input and then run for 0 with value 0 and k equal to n, I think. This is 3-dimensional, this is 2-dimensional, 1-dimensional, 0-dimensional is just a node. In this case, we have just a single node. Otherwise, we have a node and we have a job of doing something. We will first do that. For example, from 2 I will mark 6. Then I will find any unmarked, any not yet visited neighbor. Not visited. Then that, okay, minus 1. From 2 I will find 6, from 5 I will find 3. Alright, what do I put here? I hope something like this will just work. I hope. For k equal to 1, it's 1. For k equal to n, I want to say this. Let's see how it goes. I need to read the input anyway. I will by default put -1s there to see if maybe I missed something. If I didn't assign a value, it will still be -1. we got something. It's even equal to this 0132. That's promising. And what else they wanted? Colors. He's asking for an isomorphism mapping of the given graph and an usual hypercube. Then something about coloring. That's true indeed. Sorry if I don't talk too much today. It's just that, well, I'm participating in a contest, kind of, so I want to focus on winning. Is n a power of 2? Not necessarily. Perfectly, I would want to use XOR of positions with ones. Maybe I should look at the left graph. This one gets color 0. Traversing this edge can lead to XORing with 1, this edge XORing with 2, this edge XORing with, say, 4. But then I will get values up to 2 to the nth power. And say that this XORs with 3. In this case, I will get values from 0 to 3. I can use only 3 colors. My neighbors must be of different colors. Maybe that makes everything unique. One, two, three. I have some color too. I don't know what color. But one of them, say 1. This one says 1 and 3, so this is 2. This one says 2 to 3, so I messed up. Three different colors when looking from this guy. Now looking from this one, this must be 2. Looking from this one, I see 2 to 3. Damn it. Again, I messed up. Oh, there is no way to color the cube. You can print -1. That's surprising. I need to figure out if that's possible in higher dimensions. If not, then this is extremely stupid part of the problem. So let's assume that it is possible. I will close that program and instead let's go full screen. Alright, we have our hypercube in 4 dimensions. Now what? 1, 2, 3, 4. This one already sees 1 and 2. So this must be 3 or 4. 3 or 4. Maybe 4. 4 seems better. Earlier I got some kind of... it wasn't good that I used to. Yeah, because from here, this says there cannot be 2 there. So this must be 4. But this is already 2, 3, 4, so this is 1. And we'll get some kind of opposite stuff on the other end, I guess. This one says 1, 3, 4, so this is a 2. This is 1, 2, 4, so this is a 3. This is 1, 3, 4, 2, that's correct. 1, 2, 3, 4, that's correct. Right. Can I do whatever here? 1, 2, 3, 4. Because I need another color now. And let's say I did 1 and 2, 3, 4. Or maybe on opposite ends I want to have the same thing. So 2 versus 2 on the diagonal. This is a 4. This is a 1. This is a 3. Then did I get connections between same colors? 2, 3, 3, 1, 2, 4. Whew. If you want to scare somebody to make them not do competitive programming, you can show them this drawing. Alright, now how do I implement it? Well, the other cube was the same, right? Left cube and right cube, they don't differ. What drawing would you show them? I don't know. Generally, I know what to do if n is a power of 2. I see an easy construction in that case. In particular, here we have 4 dimensions, so maybe this is why it worked. I'm not going to draw it for 5 or 6 dimensions. 5 is doable, but I suspect that 5 will be impossible for some reason. But is 6 possible? Why was 3 impossible? because this one says that there will be one over there, and there can't be. The same color cannot be in distance 2 from each other, because it means it's the same neighbor. Maybe it's an important observation. Two nodes with distance 2 between them cannot be painted with the same color, because they share a neighbor. I see. So those are 4 nodes that are distant from each other by 2, and they need different colors. This is a sequence of numbers where each next one differs by 2 positions. This represents position in our hypercube. So because of it, we need, if we have at least 3 bits, then we need at least 4 colors. No. What am I saying? I guess I used that. I guess the drawing corresponds to those numbers. If there are at least, what? I used here 4 dimensions. That's bad. This drawing has only 3 dimensions. This is 0, 0. This is 1, 1. Then I switch some stuff to get this 1, 0, 1, and I switch some stuff again. See, like that. If there are at least 3 dimensions, then you need at least 4 colors. This is the only thing that we know from that. Yeah, so what? How am I doing? Did somebody finish already? Yeah, no. Not yet. Somebody solved E, Golovanov solved E in 25 minutes with a wrong attempt. So I didn't lose yet. How can I say this logic works for 4 dimensions? I won't be surprised if the code is the same. we will use the same recursive function. Can I just say that all the this is 4. What are nodes with distance 2 from me? The 1, 3, and 2. So I choose my neighbors in some way. 2, 3, 1. And then the other part of the cube I reverse. Or everything connected by a diagonal will be the opposite. Then I go to the other hypercube and I copy it. And this completely doesn't work for more dimensions. I don't know what I would need to do. I'm too stupid for this shit. Oh, actually, me too. I don't see a solution either. The link is messed up. Oh. Sorry about that. The link command works now. I still don't know. 15 more minutes and I will give up and start asking you the chat for the help. For some help. Maybe 20 minutes. For those who maybe joined recently the stream, I will say what's going on. We have a hypercube. Everybody knows how a hypercube looks like. And we need to color it now so that for every node, all the neighbors would have different colors. If we have n dimensions, it means that every node, it has n neighbors. They should be in different colors. This is proper coloring for n equal to 4 dimensions. This is not a real contest. During a real contest, I wouldn't be able to communicate with anybody. You wouldn't be able to see my screen even, because you would copy my solutions. If I solve it with help from the chat, then I will cancel my virtual participation. I will submit out of contest. And here it's still very surprising that there is no solution for 3 dimensions. I guess that there isn't a solution for 5 dimensions, and I don't know about 6. Maybe I should say that 0 is actually, I should say that 4 is 0. Will I solve problem from Sierra's certs? Not now, I'm doing something else. So problems from like regional contests, Olympiads, they are too hard for me to just, take a look and say something about it. So no. This thing, if n is a power of 2, I don't think it works. No, it does work. I can try that. I see how to solve this if n is a power of 2, because then if I move through dimension d, I will XOR color with d, and that's that. I will try that and submit it. Color of the vertex numbered i-1 in the permuted. Okay. C will be the color. Now A is node, like for example 0, no, A is number in this new thing. What do I do there? Shouldn't I say P of A is value? No, value is the original value. So it should say C of B. Yeah. And now this XORed with dimension. Dimension -1. If n is a power of 2, then we print the colors. Else we print that it's impossible. I should have first checked with samples what's going on there, like do I correctly detect if it's good or not. -1s. Zero, 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 1, 1. If I get accepted here, I won't feel satisfied anyway, because I made some guess. Does it work on first test? No, it doesn't. Debugging time. It will be so annoying. Let's see what my code does. I find first my own site with 2 dimensions. Then I find some unvisited neighbor and I run him in 2 dimensions. This always is a plus. Yeah, that's fine. The only thing how this differs is this line. But there are multiple solutions, so it's not that I saw that and I knew that it's wrong. Me solving E is like you solving A. Maybe that's similar. How much time for C? You can scroll on YouTube. I don't know how much time. I guess 5 minutes, maybe 10. permutation. Oh, obviously I can also try that without thinking. 0.135. Doesn't look better. Doesn't hurt to submit. The only thing I lose is 10 seconds to do it. Now let's move it back. And yeah, I need to just draw it. There's no other way. "50 minutes to understand C." Yeah, reading C took me more time than solving it. How to close curly brackets in Genie? I don't know if there's a way for that. Drawing time. Oh, no, no drawing time. This is it. Right. So I should just draw that. Zero, one. 0, 1, 5, 2. That's good. The first side is fine. Then 7, 3. It should be 7, 4. Oh, I see. My solution is wrong. After I find the first side 0, 1, 2, 5, I go to 7, and I don't understand that I need to go in the same order. I need to get the same neighbor first. My solution is wrong. After I find a solution here, instead of going recursively for 7 and doing something there, just for each of 0, 2, 5, I need to find a neighbor such that they are connected. That's painful. Maybe we want a vector. Zero, 1, 2, 5. And find any neighbor of 0 that also is connected with any neighbor of 1. Choose any neighbor of 0, and among them look for neighbors of 5 and 1. Among them look for neighbors of 2. This is not looking good. And few people already solved it. I'm here very far away. I guessed the coloring part solution. It works only for powers of 2. For the first one, I got the wrong solution. It's good that this wasn't a rated contest for me. After doing countless amounts of problems, do you feel your problem-solving skills are still increasing? Not if I solve easy problems, but if I solve hard ones, then sure. Practicing very difficult problems helps, that's obvious. I am now thinking about implementation. What I said here about finding common neighbors of 0, 1, 2, 5, how to easiest implement it. We start from just any neighbor of 5. This will, I think it will stop being recursive solution. It will be iterative. From k equal to 1, or from level 1 to k, up to k, we'll repeat something like we already have 0, 5, then we're looking for neighbors of 0, 5 that are connected. Those are 1, 2. And so on. One, two, three. N times we will repeat some process. For my current vector, I want to find neighbor of everybody so that they would be connected with some neighbor. Won't it be slow? 2 at 16th isn't a lot, so it's fine. First, for all numbers, my neighbors will be considered good. And now, 3, 7, 4, 6, they are good. And now for everything like 7, not only it should be good, but it should contain good neighbors. Must contain good neighbors whom I already chosen. Should I start by saying, okay, let's say 7 is taken and work with that? And now maybe even recursively with DFS, take everybody who is neighbors with 7, with at least one taken element. Among edges of the first element in vector me, if not taken, then this. 7 is the first taken element. It's here, 7. Then I will later change this name. 7 makes sense here for the drawing. Then in order here, well, if that's the first element, then continue. I already found your neighbor. But other than that, there are the edges, and it needs to be neighbors with somebody already taken. I don't know if that's enough. I think so. Let's say that whenever we take somebody, we will put them here. Like this. And for all the neighbors of X, if I take 7, I will mark 3, 4, 0 as good. So later when somebody looks at 4, they will say, this is an okay value to take. Add. First, for 0, I will find 7, and I will say, okay, I take 7. And for everybody other than 0, if this is not taken, but it's good, then take it. What's the way to... I don't remember. Day, insert, pushback. Yeah, I don't remember. There was a way to, in one line, combine two vectors. Okay, we got something. As I go, I need to also grab values, but let's see. Nothing was changed other than some small stuff there. That's promising. 0, 1, 7, 4, 5, 2, 3, 6. Okay, this is correct. And now what? Permutation. If I see that next to 0 there is 50, then I should say that 1 changed to 50. No, that's the permutation. No, I need to figure out colors, not that. How do I figure out colors? That's XOR of positions with something. color of 0. Now we are using me of I. Something and that. And what do I put here? Maybe me of I. I don't think that's that. Might be the other way around. Might be inverse. Also, if this, only if power of 2, then we do that. Well, I will submit 2 versions and then think which one is correct. Like that, and I think here inverse me. Oh, this is bad. I passed the first test. Okay, I think I got it. Easy. I have no idea what happened, but accept it. This wrong submission is unlucky. I thought that I didn't want to think if here I need to use this array p or the inverse of that, that says for every value where it is in the original graph. I just wanted to submit both versions, hoping that one will get wrong answer on test 1 and that isn't counted, and the other will get accepted. Well, not the best result out there. 5th place, and somebody can still beat me. But the first 4 problems, was I the fastest? I think so. Yes, I was winning. So just E took a lot of time. Congrats to Geothermal for solving E so quickly. I will tell you what I did there at the end in E. But don't treat this as some kind of formal editorial. Also, I wasted almost half an hour thinking about colors, maybe just 20 minutes, and then went with my first idea, what I can do anyway, and that worked. I'm not happy about it, because I don't know why only for powers of 2 it works. So how do I find the mapping? So how do I know for this input graph which vertex is which? I choose any vertex and I say that this is 0. Let's say this one, 0. I find any neighbor and say that this is 1. And now I want to find 2 and 3, right? 0, 1 corresponds to dot 0, 1. And now I want to find 2 and 3. And I'm I can either find 2, 6 here or 0, 7. Both will work. What I do is the following. In my sequence so far, my sequence right now is 1, 4. This is vector me in my implementation, 1, 4. I look at the first one, the first element, that's 1, and I try to find any non-taken neighbor. So in whatever order the neighbors are given in the input, I take the first of them. Let's say that this first guy is a 0. Okay. So I take it and I say that this corresponds to 2. Well, actually, I don't keep the mapping, I just add it at the end of the vector, so, comma 0. Alright, now I mark neighbors of 0 as possible. So 5 is fine, 7 is fine, 1 is fine. And now for a 4, what I do is I look for neighbors of 4 and I'm looking for something that is marked as OK, the green good. And the only such thing looking from 4 is 7. Like, neighbors of 4 are 1, but that's already taken, like that's already in this vector. 6 is not marked, and 7 is marked as good. So I take 7 as well. And that's a new vector. Now 1, 4, 0, 7. 1, 4, 0, 7. It corresponds to 0, 1, 2, 3. Alright. What happens next? So one more iteration of my algorithm. Already 1, 4. This color. So this is mapped to those. And again, I look at the first element, that's a 1. I take any neighbor, any of its neighbors, that's a 2. And I add it at the end of the sequence. And the sequence will be continued. I mark neighbors of 2 as possible, that's 6 and 5. And for the rest of my sequence, 4, 0, 7, for each of them I'm looking for neighbors that are marked as good, so neighbors of 2. First is 4. So I'm looking at 4 and I want to find neighbor of 4 that is marked as good. Oh, that's 6. And it marks neighbors of 6 as good as well, so 3 gets marked. The idea is that if 1 is neighbor with some things and 4 is neighbor with something, then they must be neighbor. So alright, I took 6. Continue through my sequence. For 0 I will find a neighbor, and for 7 I will find a neighbor. Ignore the colors of this sequence, but that's my permutation. This is one part, and the other, something where I don't know why this is enough, is that just put color 0 somewhere, let's say here, doesn't matter where. This is 0, and whenever you move through this dimension XOR with 0, whenever you move with this in this dimension XOR with 1, and in this dimension XOR with 2. So when you move to the right, don't change anything. When you move there, change by 1. Up, change by 2. There, change by 1. So XOR with 1, that's 3. Here, change nothing, 3. Here, XOR with 1, that's a 2. Here, XOR with 2, that matches. Here, XOR by 0, that's 1. This is how I change colors. It's trivial that if I apply this, then the condition is satisfied. I mean, what I want is from a node to look at all its neighbors and to say that they have distinct colors. But if I had color C here, and here it was C XOR 0, C XOR 1, C XOR 2, C XOR 3, then they are different indeed. But this has some requirement. N must be a power of 2. N being the number of dimensions. So in the input, N must be 1 or 2 or 4 or 8 or 16. Only for those n's my solution worked. Because then color XORed with anything from 0 to n-1 will still be in proper range up to n-1. If n is not a power of 2, then color XORed with something will be messed up. For example, say n is 6, you're looking at color 3, and you XOR it with 4. So your neighbor will get color 3 XOR 4 equal to 7. But that's not valid. This is not from 0 to n-1. This shows why the XORing solution doesn't work for n not being a power of 2. But I have no idea why in that case it's impossible to create proper coloring. Number of vertices of each color must be equal. Right, but... Oh, the number of vertices, I thought that this is the number of the vertices and this must be divisible by n, which it is. But we just want this to be divisible by n. So n must be a power of 2. That was so easy. Okay. This can be integer only if n is a power of 2. Otherwise, that's not divisible. We will not get the same number of vertices of each time. I was aware that the statement told us about the same number of vertices. I just thought that, I stupidly thought that this is the number of vertices, n times something. Right, so I understand. Oh. Okay, so what now? I want a tutorial. How do I get it? That's a lot of hints. Finding the permutation. Powers of 2 must be connected to 0. We mark neighbors as powers of 2. They repeatedly want to find a vertex connected to the same set of neighbors as from before by remembering the mapping. It's different from my method. All right. And the second part is easy. This drawing isn't similar with mine because I had a little bit different. So for them, this dimension between 0 and 1 doesn't change a color. For me, dimension between two cubes didn't change a color. But this should be isomorphic with that. Right. Well, the problem defeated me. Let's see how much time I spent. Dun, dun, dun. 29 minutes on first 4, and then almost an hour. Hour minus 5 minutes, 55 minutes. Did I like the contest? Let's be honest. People like contests more if they do well. So the strongest feeling right now for me isn't that problems were good or bad. I sucked solving E. Let me go through problems again to give my opinion. First, fine, whatever. Second, okay. C. The solution was perfectly fine. I like it, but the way to implement the statement was terrible. I didn't know what was the race. You can play races and assume that you win each race. So what? What does it mean? Why do you even write it? I don't know what is a race. What does it have to do with probabilities? Statement 0 out of 5. Well, I was able to understand it, so it isn't that bad. 2 out of 5. 2 stars out of 5. The solution was fine. I like the problem. I like the solution. So the algorithmic part was okay. Like, it's very unusual that the complexity is what? Let's try to write down the complexity. V was at least 0.1, and this made us to at most 20 times branch out. So the complexity is of 2 at power 1 divided by V, no, 2 divided by V. That's the time complexity. I never saw this time complexity. That's interesting. Is there another way to write it? This is also 4 at power 1 over V. So that's square root of level V 4. Am I right? 2 over V to second power? What? No, of course not. Oh, you're saying that that can be solved like that. Yeah, because the states to which we get are only limited. I thought about DP as well during the contest, like while I was solving the problem, but it wasn't necessary. So I agree, this recursion will visit the same states a lot of times, so obviously speed it up with DP. NFS, Need for Speed Most Wanted stream, as I told you, Underground 2. Maybe, aren't they doing Underground 2 remake? Remastered? Once this comes out, maybe I can do a stream playing Need for Speed Underground 2. So, see, solution perfectly fine. D. In D, there are those problems when it hurts you to think about it because it's very easy to mess it up. It was one of them. I would say that the statement is more complicated than the solution. And I'm not talking about the story. The way to, shortest possible way to describe what's happening is more complicated than the description of a solution, I would say. And then it means the problem isn't that good. It's bad if you need to spend a lot of time explaining the system, the properties, what's going on, to then say, oh, the solution will be like that. That's bad about problem D. Still, not a bad problem. Just not a perfect one either. And E. I feel bad about messing up the coloring part. Now that I see it, I would say, still, coloring part was very standard. I saw that type of coloring many times. This is why immediately I knew that for powers of 2 I can do it. Maybe I don't like how we need to do both. Those should be 2 separate problems, shouldn't they? Because you require 2 problems and you say that we get points when we do both of them. Still, of course, the code is kind of the same, so it makes sense to pack it in one big problem. But I'm not a fan. Right. Generally, the contest, I think, a standard one. It wasn't worse and it wasn't better than an average Codeforces Division 2. That being said, I don't participate in out of Division 2 contests, so maybe I don't know. Maybe I'm wrong in judging it. Alright, chat. Hope you enjoyed this. I will wrap it up. Just going quickly through comments to see if there's any interesting discussion. Yes, of course, I'm looking for comments made by stronger participants. Or memes. Interactive problem not being a binary search. That's an upvote. Wanted to tell you, in problem D, XOR is commutative and associative, so you don't need to keep an array. It could have just put n XOR n minus 1. So the thing was there that I did a minus, not a plus. This is what confused me. Maybe I should take a look at the tutorial to see what you're talking about. N XOR n is 0. That's not true. N XOR n isn't 0 in this problem. I think I did this. Yeah, I think this is my solution. Right, so what you're saying is indeed true for first D1, where we have XOR, and it has those properties you mentioned, commutative and associative. I don't know which one is which, but here it doesn't hold that many properties. All right. So, thank you all for watching. I will see you most likely this Saturday. I will solve coding interview problems then. Right. Have a nice evening. See ya. Bye. Do I play chess? Not actively.